We're going to solve section 5.4, solving radical equations and inequalities. Remember, we're going to have the objectives is I can identify radical equations and inequalities. I can solve radical equations and inequalities. I can identify extraneous solutions of radical equations. I can solve real-life problems involving radical equations. So we're going to start with these problems that is kind of a warm-up. So I have two students solve the equation. So you have the following equations as shown. Justify each solution step in the first student solution, then describe each student's method. Are the methods valid? Explain. So student number one, I'm going to explain what it happened. So first, wrote the equation. Student wrote the equation. Then what happens? Elevated or square each side. So you can write here, let me use a color one, square each side. And then what happened? Simplify. So we simplify. And then what happened? Combine like terms. So that's what happened when we move terms back and forth. We have combine like terms. Then what have we factor out from this point to this one? We factor. Then what happened? Zero product property. I'm going to write zero product property. And then what happened at the end? Simplify. Okay. And then problem number two is a student number two used a graphing calculator. It can be decimals, it can be a graphing calculator. So both methods are valid. I'm going to say both methods are valid, right? And which student is correct? If you look at this one, there is a mistake here. If you check this one. So in this case, which student is correct? Student number two. Of course, it's a graphing calculator. So student 2. Okay. Now on this one, where is the mistake? The mistake is here. X equals -3 is not a solution. So x equals -3 is not a solution. That's the mistake. Like, remember, when you solve quadratic radical equations, you need to try your solution, test your solution on the original equation. For example, you have -3. -3 plus 2 is -1. There is no value in the radical that is going to give you -1. That reason why this one is incorrect. And if the student is going to present both solutions as your answer, then the problem is incorrect. You need to tell me which one is the right solution, which one we are not going to use. And this is what we call extraneous solution, right? Here in the objective, extraneous solution. That's what we're going to call. So x equals -3 is not a solution, since at that point they will not intersect at that location. Now here, C part says, explain how you might solve the equation 9n 3/2 minus 7 equals 2, 20. Well, step number one, we're going to add 7. The 7, we're going to move it to the right side. So add 7. That's going to be the first step. Now look at this. I have 3/2. So I'm going to raise each side to the power of 2/3. So I'm going to do the reciprocal of this fraction. And then final, you have 9 times n. So I'm going to divide by 9. Okay, that's going to be the steps that I'm going to take. Now we're going to solve equations. This is you turn your page around. We're going to solve equations. So I have, remember that solving equations, a radical equation contains radicals that have variables in the radicands. An example of a radical equation is 2 square root of x plus 1 equals 4. Okay, so steps. Step number one, you're going to isolate the radical on one side of the equation if needed. Then we're going to raise each side of the equation to the same exponent to eliminate the radical to obtain a linear, quadratic, or other polynomial equation. And finally, we're going to solve the resulting equation. Example number one. Now, look at this equation. I have 2 square root of x plus 1 equals to 4. 2 is multiplying the radical, so we need to leave that radical alone. So I'm going to divide both sides by 2. So I'm going to divide by 2. So these 2 get rid of that 2. And I have square root of x plus 1 equals to 2. Now we're going to elevate to the power of 2 both sides of the equations. Okay, these 2 is going to cancel the radical. So I have x plus 1 equals to 4. And then we're going to get rid of this negative 1, this positive 1 by using the opposite, negative 1. So these 2 goes away. So x is equals to 4 minus 1, 3. That's my first equation. You can try the solution all the time. 3 plus 1 is 4. Square root of 4 is 2. Times 2 is equals to 4. So this one checks the answer is correct. Now look at this problem number B, or letter B. Cube root of 2x minus 9 minus 1 outside the radical equals to 2. Step number 1, get rid of this negative 1. So I'm going to use plus 1 plus 1. So these 2 goes away. So I have cube root of 2x minus 9 equals to 3. Now I have cube root, so I'm going to elevate both sides to the third power. So I'm going to elevate to the third power. So this 3 cancels these radicals, so I have 2x minus 9 equals to 27. Okay, now I'm going to add 9 plus 9. So these 2 goes away. So 2x is equals to 36. And then we're going to divide by 2. So x is equals to 18. And this one is going to check in the radical. We already proved those solutions. I'm going to give you all the problems that they can check inside the radical. If you want to do it, we did the first one, you can do the second and the third and the fourth one. And so we can save time. So we're going to see, I have 2 square root of x plus 2 equals to 8. So in this case, I'm going to divide by 2, both sides of the equation. Divide by 2. So then I have these 2 goes away. Square root of x plus 2 is equals to 8. Now we're going to elevate to the second power. Okay. Second power. So these 2 cancels the radical. So I have x plus 2 equals to, in this case, you have 8 to the second power is 16 here. Well, I have a mistake here because we divide by 2, 8 divided by 2 is 4. This one is 4. This one is 4. Because I have 4 to the second power equals 16. Now this one is 16. And then I had that 8 that I needed to divide by 2. 4 to the second power is 16. Then we subtract by 2, minus 2, minus 2. Okay. And these 2 cancels out. So x is equals to 16. Minus 2 equals to 14. And this one will give you the solution. So 14 plus 2 is, in this case, 16. Square root of 16 is 4 times 2 equals to 8. Now, problem D. So I have this minus 2. I'm going to get rid of this minus 2. So plus 2 plus 2. So these 2 cancels out. So cube root of 2x minus 5 is equals to 5. Then it's a cube root, so I'm going to elevate both sides to the third power. Now I have 5 to the third power is 5 times 5 is 25 times 5, 125. So I have this cancels out. 2x minus 5 is equals to 125. So see this 5 plus 5 plus 5. So these 2 cancels out. So I have 2x equals to 125 plus 5 is 130. And then we're going to divide by 2. And 130 divided by 2 is equals to 65. 65 is my solution for problem D. We're going to have example number 2. In this case, is an application modeling for real life. So we have the mean sustained wind velocity in meter per second of a hurricane is modeled by VP equals to 6.3 square root of 1013 minus P, where P is the air pressure in millibars. At the center of the hurricane, estimate the air pressure at the center of the hurricanes when the mean sustained wind velocity is 54.5 meters per second. So what I'm going to have here is VP. I'm going to write the equation. VP is equals to 6.3 square root of 1013 minus P. What I'm going to do, remember that you're giving me the air pressure. This says, estimate the air pressure of the center of the hurricane when the mean sustained wind velocity is 54.5. This is VP. So VP is equals to 54.5. So I'm going to make that substitution. So I'm going to have 54.5 equals to 6.3 square root of 1013 minus P. Okay. Remember what they want? The air pressure. They want P. They want to know P. Okay. So I'm going to divide 6.3 in this case and both sides of the equation. 6.3 divided by 6.3. These two goes away. So 54.5 divided by 6.3 is equals to 8.65. 8.65 equals to square root of 1013 minus P. Okay, we elevate this one to the second power to get rid of this one. So what we have is 74.8 equals to 1013 minus P. Now let's get rid of this negative, this 1013 minus 1013. These two goes away, so I get negative 938.2 equals to negative P. Okay, so now we multiply by negative 1 both sides of the equation, and I have that P is equals to 938.2. That's going to be the solution to the problem. Remember, this is a question. Estimate the air pressure. So you can write the air pressure at the center of the hurricane is when the sustained velocity 54 meter per second is 938.2, in this case millibars. Remember that air pressure in millibars. So this will be the actual solution. Okay, let's look at example number 3. Example number 3, A and B. Okay, what we're going to have. Look at this one. I have x plus 1 equals to 7x plus 15. So I'm going to elevate both sides to the second power. Okay, I'm going to open parentheses to the second power. So x plus 1 to the second power is a binomial to the second power. So it's the same as having x squared plus 2x plus 1 equals to 7x plus 15. I'm going to move all these expressions to the left side. So I can do minus 7x minus 7x minus 15 minus 15. So I have x squared minus 5x minus 14 equals to 0. Now I'm going to factorize, and I have negative 5x, I have negative 14, so I think this one is x minus 7, and x plus 2 equals to 0. Negative 7 times 2 is negative 14, negative 7 plus 2 is negative 5. And then we're going to apply zero product property, so I have x minus 7 equals to 0, or x plus 2 equals to 0. So x is equals to 7, or x is equals to negative 2. Now you need to check the solution on this one for extraneous solution. So I'm going to start with a negative number, negative 2. So I have negative 2 plus 1 is equals to negative 1. Definitely this is not the solution, because it doesn't matter which number you plug in x, you are never going to get a negative number out of that radical. So x equals negative 2 is the extraneous solution. So my solution is x equals to 7. Let's do b. So I'm going to move this 4 to the right side. So negative 4 minus 4. So I have square root of 2x plus 7 equals to x minus 4. Now we're going to elevate to the second power. Okay. So this 2 goes away. So I have 2x plus 7 equals to x squared minus 8x and plus 16. Okay, plus 16. And I'm going to move this binomial to the right side. So minus 2x minus 2x minus 7 minus 7. So what I get 0 equals to x squared minus 10x plus 9. Let's factorize. Xbox method you want to use. 0 is equals to, I have 9, I have negative 10. So it will work x minus 1 and x minus 9. Negative 1 times negative 9 is positive 9. Negative 1 plus negative 9 is equals to negative 10. So applying zero product property. So I have x minus 1 equals to 0 or x minus 9 equals to 0. So x is equals to 1 or x is equals to 9. We need to try for extraneous solution. So this time I'm going to give it a try to 1. So I have 1 here. So 2 times 1 is 2 plus 7 is 9. Square root of 9 is 3 plus 4 is 7, which is not equals to 1. So x equals to 1 does not work in this case. Okay. So in this case, it's going to be x equals to 9. You can plug in 9 and then you can try get the solution. Example number 4, I have 2 radicals now. I have 2 radicals in this case. So I need to get rid of the radicals. It's going to be a little bit more tedious. This one is going to be a little more tedious, more steps. So for example, in this case, what I'm going to do is elevate both sides to the second power. Okay, they are square root, so I'm going to do to the second power and to the second power. As you can see, this is a binomial. This is a binomial, so we're going to treat it as such. So for example, in this case, what I'm going to do is I'm going to apply, I have the square root of x plus 2 plus 1 to the second power. You can separate that binomial. So I can do square root of x plus 2 plus 1 times the square root of x plus 2 plus 1. This one, if you don't want to use the formula. So if you multiply these two, is a radical to the second power, so the radical will go away. So I have x plus 2. Then I have a square root of x plus 2 times 1 plus square root of x plus 2. Then 1 times the square root of x plus 2 is plus the square root of x plus 2. And then 1 times 1 is plus 1. Since I have 2 radicals, they are the same. So I have x. 2 plus 1 is 3. But I'm going to leave that one at the end. So plus 2 square root of x plus 2 plus 3. So this is what happened when we multiply that binomial 2 times. So what I'm going to have here is x plus 2. Okay. Well, if we simplify, we can simplify x plus 2 square root of x plus 2 plus 3 equals to 3 minus x. Okay, equals to 3 minus x. So now I'm going to do is move everything to one side and leave the radical alone. So for example, I'm going to do minus 3, then minus x. So these two goes away, these two goes away. So I have 2 square root of x plus 2 equals to 3 minus 3 is 0. And negative x minus x is negative 2x. Then I'm going to divide by 2, both sides. So I have a square root of x plus 2 equals to negative x. Now what I'm going to do, elevate again everything to the second power. That reason why I said it was a little bit tedious, this one. So these two goes away. So I have x plus 2 equals to x squared. Now I'm going to move this binomial to the right side, so I don't have negatives on my leading coefficient. So negative x minus 2 minus 2. These two goes away. So 0 equals to x squared minus x minus 2. We're going to factorize now. I have negative 2, negative 1, so I have 0 equals to x minus 2, x plus 1. Zero product property. X minus 2 equals to 0, or x plus 1 equals to 0. So x equals to 2 and x equals to negative 1. Which one is the Stranius solution? We are going to test this one. So I have 2. 2 plus 2 is 4. The square root of 4 is 2 plus 1 is 3. So I have 3 on the left side. And then I have 3 minus 2 is 1. The square root of 1 is 1. 3 is not equals to 1. So x equals to 2 is not the solution to this problem. Negative 1. Negative 1 plus 2 is 1. The square root of 1 is 1 plus 1 is equals to 2. And then I have negative 1. 3 minus negative 1 is 3 plus 1, which is the square root of 4 equals to 2. And 2 is equals to 2. So this one is my actual solution. Problem B. So I'm going to have elevate both sides to the second power. Okay, I'm not going to take that many steps on this one. So I'm just going to elevate to the second power. So I'm going to have x plus 6 plus 2 square root of x plus 6 plus 1 equals to 7 minus x. Then we simplify everything. So I have 2 square root of x plus 6 equals to negative 2x. Can you see the pattern that we're having with these equations? Then we divide by 2. So I have a square root of x plus 6 equals to negative x. Elevate to the second power. So I have x plus 6 equals to x squared. So I have that 0 is equals to x squared minus x minus 6. 0 factorizing. So I have x minus 3. X plus 2. So I have in this case x equals to 3 or x equals negative 2. And from this one, the first one is not the solution. You can go back and try that number and see if that's correct. In this case, I did it. X equals 3 does not work. X equals negative 2 work. Example number 5, we have 2x to the 3/4 plus 2 equals to 10. Remember, in this case, first step is getting rid of these 2. So minus 2 minus 2. So I have that 2x to the 3/4 is equals to 8. Now we're going to elevate both sides by the reciprocal of that fraction, which is 4 over 3. Both sides, 4 over 3. Now, what's happening with this 8? This 8, remember from the previous section, we have 4 over 3. So we can have the same as 8 to the 4th to the 1/3. What is 8 to the 4th? 8 to the 4th is 4,096, in this case, to the 1/3. What is 1/3? It's just the cube root of 4,096, which is 16. So what we have here, these two cancels out. So these two cancels out. So what I have is 2x equals to 16. Then we divide by 2. So x is equals to 8. And this one is going to be the solution. We don't have to test the solution on this one. Now let's look at this one. So I have x plus 20 to the 2/3 equals to 4. And I'm going to elevate both sides by 3 over 2. 3 over 2. Same situation. So I have 4. 3 over 4. Wait, 2 over 3, 3 over 2, 3 over 2, 3 over 2. I forgot that, 3 over 2. So what we have here is 4 to the 3rd power to the 1/2, which is the square root of 4 to the 3rd power, which is 4 to the 3 is 64, and the square root of 64 is 8. So what I have here is x plus 20 equals to 8. And then we subtract minus 20 Okay, so these two cancels out. So I have that x is equals to negative 12, which is the answer that we're looking for. And now we're going to the next example. Example number 6, I have two examples, A and B. I have an equals to x in both sides, and this is the indication that we're going to have to try the solution and look for extraneous solution. Okay, that's when we're going to be doing extraneous solution. Now in this case I have x plus 30 to the 1/2. The reciprocal is 2, so I'm going to elevate these 2 to the second power, both sides. So what I have here is x plus 30 equals to x squared. So I'm going to have that 0 is equals to x squared minus x minus 30. Now we factorize 6 and 5. So I have 0 is equals to x minus 6, x plus 5. 0 product property, I'm going to have x equals to 6, x equals to negative 5. Now we're going to try the solution. By default, I'm going to try the negative number because I have an equals to x. Remember that this 1/2 means you have the square root of that expression. So you're not going to get a negative number coming out of this parentheses equals to another negative number because it's not possible with the square root of this expression. So x equals negative 5 is not the solution. X equals to 6 is your solution. Problem B, same. We elevate to the second power, both sides to the second power. So what I have here is x plus 12 equals to x squared. So I have that 0 is equals to x squared minus x minus 12. Then we factorize. So we have x minus 4 and x plus 3. So I have that x is equals to 4 or x is equals to negative 3. Again, I have an equals to x. If you have a negative, it's not going to work. So my solution is x equals to 4. Now we're going to move to example number 7. We're going to solve an inequality. So in example number 7, in this case for A, I'm going to check the domain. The domain, remember, we're going to take what is inside the radical, x minus 1, and it has to be greater than or equals to 0. So x is greater than equals to positive 1. Positive 1. Okay, anything less than positive 1 is not going to be part of the solution. So now we're going to proceed to solve it like we've been solving it before. We're going to divide by 3. Divide by 3 in this case. So these two cancels out. So I have the square root of x minus 1 is less than or equals to 4. Now we're going to elevate both sides to the second power. And I have x minus 1 is less than or equals to 4 to the second power is 16. And then I'm going to plus 1 plus 1. So I have x is less than or equals to 17. Okay, so that's what I got here. But remember that this one combines with the domain. So it's like if we graph this expression here, if we graph this one, what we will have is something is starting at 1, and then it will go grow into positive infinity, and we're going to have at some point here crossing through 17. And so my solution in this case, I'm going to have 1 is less than or equals to, remember the domain, x, and less than or equals to 17. That's going to be my solution for example 7a. For example 7b, in this case, remember that in this case the domain is x is greater than or equals to 0. So everything from 0 to positive infinity is going to be part of the domain and part of the solution. So in this case, we're going to plus 4 plus 4. So these two goes away. So I have 3 square root of x is greater than or equals to 12. And then we divide by 3. Okay. So square root of x is greater than or equals to 4. I don't know, changing the colors. 4. Then we elevate to the second power. So I have that x is greater than equals to 4 to the second power, which is 16. Okay, so I have that one as my solution. And in this case, remember, start from 0. So I don't need to write 0 is less than or equals to x. So this one is my actual solution. You can just test the points and you will get those points. It would be different if this one were less than or equal. If this one were less than or equal, we will have 0. This case is less than or equals to x, less than or equals to 16. But in this case, it's just x is greater than or equals to 16, and we just graph those points if you want to use the graph. So if you have any question, let me know, and have a wonderful day.